Good morning, everybody. Nothing like the third day, the third morning, a quiet lull descends as people begin to wake up. The coffee is quite good. If you get here early in the morning, you're allowed a special coffee, as myself and Julian found out, but no longer. So I hope you're all enjoying your time here at Space Resources Week. It's the last day already. It's gone very quickly. Thank you for being on time, because we have a wonderful day ahead, a really, really wonderful day. Of course, yesterday we had the UNOSA meeting in parallel. Today we have more parallel sessions after the first coffee break, after lunch time also. That will be moderated by Larry from ESRIC. And as always, huge thanks to all of the event partners which make this event so wonderful. So this morning, the panel is, the speakers will be moderated by Olivier Zephir from Technoport here in Luxembourg. And the theme is commercial initiatives, dual market case studies, public-private partnerships and market needs. So they're going to cover an awful lot. And with that, please welcome Olivier Zephir to the stage. Thank you.
Thank you. Thank you so much, Lisa. Third day, early morning, coffee is good. Indeed, it is. It's my very great pleasure. I'm Olivier Zephir from Technoport, the technology business incubator based here in Luxembourg. We host a significant number of space tech companies, and some of them are addressing the challenge of space resources. So it's my great pleasure, not to repeat again, to address that topic of the day, how for economical operators, and I mean it, economical operators are taking the challenge of addressing, bringing to market commercialization of space resources. So we will have this opportunity of sharing with them about their use cases. Remember, you can ask questions online, but I'll further bring it to them. So without waiting, let's call on stage Mr. Wasilewski from OffWorld for the first use case.
Good morning. How are you doing? It's amazing to see how this community has grown over the years and how it was decimated yesterday. So, first, I would like to thank the LSA and ESA for the continued support in the project that I'll share some details about today, as well as to thank the NASA, DoD, NSF for their support across the pond. Together we're building these new robotic capabilities that will eventually unleash our potential beyond Earth. At OffWorld, we are committed to advancing sustainable human presence on all celestial bodies. Earth is our first commercial target. That is why we're building swarm robotic capabilities here with some of the biggest mining companies around the world. And with that, we've already built a foundation for a more complex development beyond Earth. The architecture we are building towards has the potential to truly change the ways we are dealing with mining and processing. With swarms of robots deployed in mines, both in pits and underground, we can enable precision mining, lowering down the cost of operations, opening new viable means to address stranded assets, as well as eventually deploy in greenfield and brownfield mines, taking people out of the harm's way. Those deployments are directly applicable to planetary environments at an industrial scale, which are our way to go. The systems we've built for Tier 1 mining companies like Anglo and BHP enable us to field test some of the advanced robotic systems, both in mobile prospecting and excavation. These robots, like surveyors in here, are capable of working in extreme and unstructured environments in areas where no humans should or can venture to. The surveyor can host a variety of payloads like GPR, spectrometers, coring drill to analyze the composition of the rock face or the ground. It can further inform the excavator bot where to precisely chisel, dig, or drill, which enables precision mining. Our core capability is also in microwave processing. our systems, again developed for top mining companies, were deployed in mines to target the rock face, irradiating the ore body to weaken the mineral bonds, making them over 30% easier to excavate, handle, and crush. We've also developed a microwave array system integrated with a conveyor belt and utilizing an advanced vision system to precision target the rocks that are transferred to beneficiation and processing, making them easier to process. And we're drawing from all these industrial, robust systems we've built and deployed so far to inform the development of lunar robotic mining capabilities, where we are expanding to slightly new domains, at first reaching for the resources that we greatly believe in, and that is water ice. Because we believe that water-derived consumables can truly transform the ways we think about space exploration and settlement. And it's obviously not an easy task, and it's a task that we don't fully understand the boundary conditions for. That's why we need Viper and Prospect, etc. But this endeavor is possible thanks to the advent of heavy launch and landing capabilities. That is why we've started development of our Demo Mission 1, first in a cadence of missions to understand, develop, and unleash the potential of PSR IC deposits. Demo 1 integrates two systems in development at OffWorld. LAMR, so Lunar Autonomous Mobile Robot, that is developed at our mother company, and LPM, Lunar Processing Module, developed here in Luxembourg. It is a minimum viable product for industrial, large-scale production of water-derived consumables on the moon. And we're starting with production of crude water, with which we'll be able to pinpoint exact treatment and processing needs for potable water, oxygen production, and storage in situ at scale in the future. That will enable us to capture a vast majority of the water value chain on the lunar surface, from prospecting and mining to separation and treatment. But we also see that the technology we are currently building can translate to orbital systems to be used in ECLS, as well as in some of the terrestrial challenges, enabling more sustainable ways of doing business, particularly in mining and treatment. The LPM functions focus on regolith handling, microwave-enabled volatiles extraction, volatiles treatment, and condensation, and can integrate more steps in processing. This is one of the prototypes we've built over the course of the last year. We are ingesting IC regolith coming from OffWorld bot or any other robot, rover or lander. We're desiccating it within a few minutes in the volatiles extraction system powered by beamforming microwave. From there, we transfer the volatile stream to instrumentation for prospecting and to condenser for low pressure condensation. And the whole system is standalone, has its own battery system, enabling its own survival and high power operations, and can potentially separate volatiles, producing not only crude, but also pure water. In a single system, we're integrating several key functions, working with both IC regolith handling and extraction, as well as gas handling and production of water. And our breadboards already demonstrated great capabilities in all of those domains, and we'll be working towards engineering and flight models of the systems in the future, targeting 2027 launch. Compared to conventional extraction methods, we're reaching very high yields at lower energy costs. Even on the lunar demonstration stage, we're already designing the systems to handle large quantities of feedstock to further improve on that in the future systems. And what we see as very important is that these developments can easily translate to systems that can be applicable in pressurized vehicles and stations way before the lunar market truly kicks off. So that further builds our commercial business case. And with that, please make sure to visit our booth and talk to our team members. And thank you so much. I hope you have a wonderful time here in Luxembourg so far. Thank you.
Please go down, stay with us, and thank you again for the great presentation. What an ambition. Question to you regarding this private-public partnership necessities regarding already the objectives that you have aligned, specifically for the moon operation. Can you tell us a bit more? How are you going to specify your role in this value chain? Because you are occupying a strategic area. How are you bringing the other parties on upline, downline of the value chain?
Right. So, I mean, the space side of business at OffWorld is largely funded through private-public partnerships with our great partners at NASA, at ESA, and other agencies. And it's one of the legs how we do the business. But thanks to the contracts with mining companies, we can also sway some of that money to move it around some of the R&D activities, and that is a really nice thing to have the ability to do. In the future, of course, it's very difficult to say how those actual mining operations will take shape. Right now, we're building towards demonstration missions. This will be largely driven by agencies with some of the private funding towards that. We truly believe that we can mobilize strategic partnerships with nation states within the Artemis Accords. This is something that's very viable towards building demo 1, 2, 3 until we can actually secure the industrial production on the moon, until we can actually secure the knowledge to have the commercial case on the surface. But until we have that, we can only make believe that we can develop something that will last until that time. I don't know. It's hard to say, but it will definitely be driven by public-private partnerships.
Thank you for that. And regarding the mining partners you have stipulated, can you share with us how is the relations with really, if we can say it, down-to-earth operators about how to share about these terrestrial applications and the space endeavors? How are they receptive?
It's a good relationship. It's a demanding relationship, challenging relationship. It's very hard to open these doors and keep them open. But it's something that those mining companies are truly interested in, which is a good sign. But working with those mining companies is kind of like working with ESA or NASA, so you probably know how it is.
So thank you so much, Gordon, for your lights this morning. I do believe the audience will have the opportunity chatting with you further. Thank you again.
My pleasure.
Please join me for a round of applause for Gordon. Our next speaker is going to be Pascal Rodel, and I call on stage Mr. Pascal Rodel from RDSO company. Dear audience, please let's welcome with a big round of applause, Mr. Rodel. The floor is yours.
So, good morning, everyone. I will be the guy that spoils your mood because we talk about technology, we talk about the wow effect and everything, and then someone says, how are you going to fund that? How are we making sure that all that is profitable? So the idea where it came from was you read all those quotes like, there will be a trillionaire in space, and then the next day you read it's impossible, and they always come up. You always have the two extremes, and you try to find out how can we actually do that. So that kind of got me onto the challenge. I have a background, I'm an engineer, so I understand the technology also, but I've been working 25 years in strategic consulting, and you have this mindset of, how will it work? How can we make it happen? So that's where this idea came from, to understand, can we find out how to build a space mining company in the future that is self-sustaining, that is viable, that is profitable? What are the steps? How do we need to think about it? So can we understand the framework and the cornerstones in order to define how such a company could look like? Can we identify what I call strategic trajectories in order to get there? And then can we simulate that using digital twin technology to say, this makes sense, this doesn't make sense, there is a certain hurdle rate that we need to overcome in order to be profitable, what can we do? So today's presentation is a bit about the first part of this story. And if we think about today's investors. This is kind of summarizing how investors try to get value out of companies. So you buy a company, then you hope something will happen, and then you can resell it for more. And that's most of today's entrepreneurs, that's how they think. Their end customer might not be the one using the product or the service that they develop, but they get funding, they can resell their company later. And it's typically based on how good are the operations, do we acquire more, do we build this company bigger, and at some point in time we put a multiple on that because it's a really cool thing in a really cool industry, and then we sell it for more money. The only thing here is, if you invest into a space startup today, there is no operation, there is no revenue. How will it look like in the future? If you want to define what sustainable operations are, somewhere you need to make a profit or a margin. It should be bigger than zero. You look to be self-sustaining. So the top part, that's ongoing steady operations. And on the right-hand side, you have some revenues, you have some costs, and somewhere there's more money staying at the end of the operating year than there was in the beginning. Well, if you start investing a long time into those companies, you kind of pour a lot of money in there, and the return on investment will take a long time to recover. There's this, what we call the project service paradigm. You have companies that develop equipment that they install, and then they sell service contracts for 30 years. And they always say, well, if the project doesn't make the costs, the service will recover the money. Most of the time that doesn't hold true because the time needed and the return that you require on those services are just too high for them to be viable in today's competition. Now, that's how we can think about space mining companies in the future. At some point in time, we will have a self-sustaining operations, meaning we survive with our own means, in a space economy that is rather mature. So the definition of what is mature is open to debate. That can be, I have a client in space, so I can directly deliver to him. Maturity can also mean I have the technology required in order to run those operations. It can also be a legal framework. So there's a lot in the term maturity. But a lot of the things we see today is we will be up there and it will be really cool. Well, there is a long walk in the desert under this threshold of profitability. Is there a way that we can jump over before so that we can have some self-funding? We have a company that actually evolves and can be called an operating company before we really come into the maturity. So how do we gap this time needed in order to be self-sustaining? If you think about the building blocks of such a company, there's obviously the vision, the mission, why are we here, what do we want to achieve? But at some point in time, you need to decide how to get there. So that's where strategic thinking comes in. We need to decide how to get there. And then we have two tools that we use for companies in order to execute the strategy. The first is the business model that defines all the different dimensions that we will use in order to be successful. Who are our customers? What are they willing to pay for? What is our value proposition that we provide to them? Why are they actually willing to pay such a price for it? How do our processes work? How do our partnership work like? Our cost structure? So that's the business model itself. And within one strategy or a strategic trajectory, you can have a lot of different business models, and they can evolve over time depending where you are in the maturity of your company. Then at the lower level, that's really the tactical one, that's the operational model. So when you talk about technology and say, like in the mining industry, I excavate something by using those machines, I work in 3 shifts and I bring it to that environment, that's the operating model. It's very tactical, very practical, I can touch it, and that's rather simple to simulate. If I build a digital twin, that's the first candidate in order to have that. On the business model level, it's a bit more complicated, but that's the ambition to be able to do that. Obviously, when we then look at all the different strategic trajectories that we can have in order to build a space mining company in the future, there are different attributes. Where are my customers? Where are my target customers? Where do I want to focus on? Do I want to focus today on the end customers that I will have in 20, 30 years? Or do I make steps and I say, well, first maybe I have some clients on Earth and then I will move them to the moon, and then, so there are different elements, dimensions that will define my strategy. And using what is typically called morphological analysis, that was used in astronomy before and still today, is out of all those combinations, there are some that make sense and others that don't make sense because the combination just doesn't hold up. So finding those combinations, finding the fingerprint of this morphological analysis and say there are certain categories and group them and say, well, there may be 5, 4, 6 different generic strategic directors that we can work on. So those are the ones that for the moment seem obvious. There's what I call the long shot. You could also call it the deep pocket approach. I'm building the operation the way it should look like later on. So I don't care about this walk in the desert. That's how it's going to be. I will focus on my end customers. They will be in orbit. They will be on Mars. I will use technology that will then exist. And until then, well, I need deep pockets, and I will have to find somewhere the origin of the funds, public, private, but someone needs to support me in order to get there. So there are some risks. The lead time to self-sustainability is obviously very long, but that's the thinking coming out of technology and this future. Then we just had a very good presentation on how do we work with today's mining companies. That would be what I call the horizontal market entry. So you have someone operating very well along the full value chain in a similar or quite different industry and is making the step horizontally into the space mining area. So that's typically a big mining company that say, we have some knowledge, we have technology, we operate well, let's make the step over. You can think about vertical market entry also. If someone has technology that is today used in space, can we expand that? Can we then make the step? If I have launches today, can I build, for example, a return to Earth orbiter? Can I work on something that slowly fills my value chain for space mining because I have already a predominant position in one of those phases today? Number 4, the value chain building is a slight variation of that. If you take, if you have seen the slide outside of Immensus, they say, we are the company that will provide the data. If you want to know where to mine, we will do the data prospecting for you. So if you think about the value chain of space mining, that's very much in the beginning. You can imagine such a case slowly working along this value chain in order to build a full company. So you start at one point and you build it up. Obviously, it depends where is your entry point, the value proposition that you have today, is there a need in the market for that? Can you make this step in the value chain already profitable? And can we sequence it in a way that we remain self-sustaining while investing in building the next step? And then you have the weather vane. In a sense, there are things going on in space today. I can provide that. I make money with that. Everything I take from that, I develop something else. Oh, there's something else that is very cool. So I kind of make my way through profitable services or products in the space industry. Hopefully, at the end, I have all the elements in order to build a big space mining company. Of course, it's risky. It's not as easy to plan, but there are different approaches to it. Quick overview, open for questions. Very happy to discuss.
Thank you so much, Pascal, for this great overview. Some question on my side, lots of questions, given this industry being nurtured. We are really at the front end of this industry. What would be your recommendation regarding clusters of actors? I'm quoting the deep pocket here, because you can find the deep pocket alone, but won't it be a strategy to find the cluster of actors being the most impactful at this given phase of the early stage of industry? What's your thoughts on this?
Well, obviously there is a deep pocket, which is public money. And somewhere in public money, there's always the understanding that there is no return on it. Yes, politically, you can always define one, but there is a deep pocket there. On the other side, you want to have clusters of long-term support. So if you think about the development of terrestrial mining, you have investment horizons of 20, 30, 40, 50 years, and then you mine a mine in Chile or northern Canada for the next 100 years. So that it's a long period. So for me, those are clusters where you have the understanding of the time horizons. And I think that is the important part in those clusters. Nothing is worse than to have a cluster out of the private equity industry that says, you know, in 7 years we need to sell and we need to make a multiple, because then you're under stress for delivering something that doesn't necessarily bring you close to your future state that you want to develop.
Thank you for that. Do we have a visibility today? Because most of the time, and you took the terrestrial example, where we expect to have this public intervention is generally infrastructure. You took a port, you took an airport, but here within space resources, what we are understanding is that these agencies are expecting to be end users. So who will be on the infrastructure? Do we have every keys on that today? Or is it going to be these initial clusters of companies who are going to play both that role?
Well, my thought on that today is, if you think about the value chain of space companies, and it can be space mining, space manufacturing, other services, there are needs of processes, infrastructures, products, and customers. If you take a business model, you have all the different aspects. I didn't show it, but you know some of the models. And obviously, if someone sees an opportunity that there is a profitable white space to occupy, and depending on how long or how deep your pockets are, you're willing to build that, it doesn't necessarily have to be public money or an agency building that infrastructure. So if you look at spaceports, for example, you can imagine private spaceports. We see it with private rocket building. So we can imagine any setup in which a piece of the jigsaw puzzle that is missing in the space economy taking over by a private player. So it doesn't necessarily have to be the big one. So for me, when I think about the space economy, I think Earth, Moon, and others, not necessarily country, national pride, and all those things that kind of hold us back in the public funding.
Looking forward to see that. Thank you again. Please, big round of applause for our presenter, for our speaker, Pascal. And now let's welcome onto stage Mr. Carlos Espejel for ispace and for another use case presentation. Carlos, floor is yours.
Good morning, everyone, and thank you for the kind introduction. So ispace, of course, ispace is a commercial entity, and I'm going to be more than happy to share with you about our commercial activities, some of them on exploration, extraction, and materials handling. Now, I'm going to make emphasis on materials handling later in the presentation, so just remember that word. Okay, so our vision is to expand our planet and expand our future through the utilization of space resources to build a sustainable cislunar economy. And we also have a 10-year milestone to be pioneers on water ice resources in 2030. Now, we're planning to achieve this with our 3 pillars, which is, of course, transportation to the moon. We are aware we need to do plenty of exploration, so that's the data business. And of course, we need to work together through partnerships for technology and commercial activities. And all of these will be ISRU enablers at the end, as we know. In terms of the ISRU vision, there's many steps and many activities that we need to do, of course. And today I'm going to share with you just 5 of those activities, and the list is not extensive, of course. So the first one is, I'm going to share with you about our M1 mission, then about a commercial and tech partnership that we're very proud of, and how with this partner we're kick-starting Lunar commercial activities. And as a commercial entity, we need to look closely at the market demand to build our strategies that we just heard about and to build technology roadmaps. And supply is very important. And when I mean supply, it's about resource availability. And this is extremely important. And at the end, I'm going to make emphasis on the need of a new market demand assessment, which I will invite you all to be part of. So in terms of transportation to the moon, our first mission was last year, and M1 mission. And this was very crucial because we started lunar commercial transportation. It was the first attempt for that. And integration started in 2022. And we launched on the 11th of December of 2022, where we reached space on the same day. And this was very important for us. It was very inspirational to us because we have been working many years on the lander, on the vision, and then this day became real. And it was inspirational for us to keep working on it and to make it happen and to prove by action. And then we were on space navigating for a bit more than 4 months, and we finally reached the moon's orbit on the 20th of March. So that's real footage from our lander. So we were orbiting around 100 kilometers off the surface. And that was a very special moment. And then, of course, the day came to attempt landing on the 25th of April. And we all know the story. We hard landed. It was a software error. It was a humbling moment, but it was with a lot of respect for the moon, of course. It gave us a lot of respect. And how do we know we made it to the moon? Well, our friends from NASA, they found us through LRO, so that's us. We did make it to the moon. And we achieved many milestones. And one of those milestones was to become the first commercial company to reach the moon. In more than one piece, but we did. And to be honest, we're very, very proud of it. And of course, we learn from our mistakes. And most important and most exciting, we have another mission, which is at the end of the year, our M2 mission. And we ask you to please cheer for us for a successful landing early next year. I will be sharing more about that. Now, of course, we need to keep working, and we need to keep working with partners. So I'm going to share with you about potentially the first long-term partnership with a mining equipment company. And this is a strategic partnership with Epiroc, where we signed a long-term collaboration agreement pretty much to work on lunar activities on missions to develop technology and commercial solutions for ISRU, and this is lunar economy, so very important. We are partnering with a mining equipment company to develop commercial solutions. And on that, we have two initiatives so far. The first one, they became a Hakuto corporate partner. And then they supply to us a state-of-the-art regolith collection system that you can see on the right. And we're going to be using to execute our NASA regolith contract that I'm going to share more with you in a moment. Who is Epiroc? It's a mining equipment manufacturing lead in the world. And they have a lot of equipment for mining and infrastructure. And they have equipment for materials handling. Remember that word? And you can see the loader on the left. And that loader, just for perspective, that bucket has a capacity for 17.5 metric tons. So imagine how much material can move in an hour. Now, on the right-hand side, you can see an operational drill. They are a tier 1 company on operational and explorational drills. And they excel on underground drilling. And the underground environment has a lot of similarities with the moon. And that was an important factor for us. Okay, so they became a Hakuto partner. Of course, they have the logos on that. But most important, with Epiroc, we're kickstarting commercial activities. And the first commercial activity is the NASA regolith contract. So as many of you are aware, NASA awarded 4 regolith contracts in 2020. We won 2 of those. And we're going to be executing one of those with the legal framework of Luxembourg of Space Resources in our M2 mission early next year. Now, to be honest, the NASA regolith contracts were a legal and commercial demonstration. But we decided to take one step further with Epiroc, and we were like, let's do a technology demonstration. So we're not going to sell to NASA just the regolith that sticks to the rover or just the regolith that sticks to the lander. We were like, let's actively collect the regolith for NASA. So we developed an extraction rover. So on the next image, which is a video that my colleague Sofia Casanova kindly shared yesterday, you can see our engineering model of the micro rover. And on the front, you see the Epiroc shovel. And you can see there's 3 compartments in the front. Each compartment can take 100 grams. And there's 3 of them. One of the compartments is for NASA's regolith. And there's other 2 compartments for commercial customers. Now, one of those compartments is still available. So if any of you would like to buy some lunar regolith, still for sale, please feel more than free to approach me or any of my colleagues. So, and within ispace, we're developing as well technology for exploration and materials handling services. Materials handling, that's a key word. So we're developing technology for exploration to identify a specific material that you need, specific rock types at specific sizes. And we're developing with partners technology to extract those resources, as you saw. And we're developing technology to dump that material and to create stockpiles. That's another key word that we're going to be using more and more. The stockpiles of specific rock types, specific minerals at specific granulometries. Why? Because we know there's entities that are working on oxygen extraction processing plants, metal extraction processing plants, and they will need specific regolith at specific throughputs and specific grain sizes. We just heard from OffWorld, they're developing technology for 100 kilograms per hour. So what we're doing in ispace, we're developing with partners that technology and those services to be ready when those processing plants are on the moon. Now the question is, at what capacity are we going to design this equipment? And when in time are we going to need these technologies and services, right? So for that, of course, we're looking very closely at market demand assessment. So there's a number of market demand assessments, and really good ones. And one of them is the one led by the government of Luxembourg with PwC. I'm not going to go through this, of course, but this is just to acknowledge that there are really good market assessments. This is for propellant. This is another one for regolith, for manufacturing, construction, and infrastructure. And of course, with this market assessment, we can start quantifying how much propellant we're going to need to produce in time. So with that, within the interest of ispace, we identify some initial markets, like for lunar construction, for infrastructure, and we know their needs. They will need someone to identify that specific regolith for construction, to extract it, to transport it, and to sell that regolith. Now, for the other lunar market, which is what I'm calling ISRU for propellant, we'll need similar needs. They will need someone to find that specific mineral with volatiles and mineralogy, to extract it, to transport it, materials handling, and to buy that propellant. But let's focus on propellant. So if we identify this market, the question is, okay, how much propellant do they need, all right? So for that, the D is for demand. So the question is, what is the resource size for propellant demand? So for instance, if we need 26,000 tons of propellant, of hydrogen, how do we translate that to a size of a resource deposit? How big the deposit needs to be that I need to explore? Now, this is just one scenario. Of course, there's many scenarios. This is one of them that we're sharing with you. And we use mining methodologies to estimate the size of the deposit. Myself, I'm a mining engineer. And we estimated on this scenario, with all its assumptions, of course, deposit size of 10 million tons. So that means that we will need to find a landing site that can have 10 million tons to supply these 26,000 tons of propellant demand. Now, the next question is there a landing site that could have a deposit size of this size to supply this market? So for that, we did a supply assessment. And for that, what we did is a resource model for hydrogen, and it's potentially the first block model of the lunar South Pole in existence. And for that, with our lunar scientist at the time, she selected one of the potential landing zones with positive neutron information. We also used the thermal models of PAGE that many of you know, of course, and we developed, using geostatistical modeling and geostatistical analysis, again, a block model. Pretty big, kind of 2 by 2 kilometers. And with that, now you can see the potential distribution of hydrogen resources on the surface and in situ, so cross sections. And with this, we estimated the amount of tons available in this landing site. But you might say, yes, of course, the information is limited. Therefore, the certainty is low. But we can already report these tonnages. So how do we report these potential resources? So for that, we use LORS, the Lunar Ore Reserve Standards. And following the classification system, yes, we acknowledge we're using remote sensing data. It's very low certainty, therefore really high geological error. And because of that, it's undiscovered resources. We cannot claim a discovery so far because it's really low certainty. And we also acknowledge that we need way more exploration, like ground truth samples, if we want to get at some point to inferred resources. So how do we classify this? So these resources under LORS are potential prospective resources. The amount of tons of resources that we found on this landing site, I cannot share with you. That's confidential. But what I can tell you is that it's way more than what we estimated for this scenario demand, which was a 10 million ton deposit. Now, of course, we need way more data. And when we start getting samples and more data, the potential prospective resources will go down for more than half. But that's the actual game of exploration. That's how it works. And we started analysis. Okay, but now let's go back to market demand. As I was saying, there's really good assessments, but we acknowledge that these assessments from 2018, they're pretty much becoming outdated. So we need to work on new assessments and update them for propellant, regolith, and so on. So in Euro to Moon, there's different working groups, and one of them is the Market and Business Working Group, which I'm leading, and we are organizing a new market assessment update where we want to be very inclusive and make it international. So we're going to be inviting LSIC and the LIVC from Japan to create a global update market assessment demand for propellant and regolith. So, and of course, once we get this data, we're going to use it to run the models that I just showed you, to run the assessments that I just showed you, and of course, with all the new exploration data we need. So I'm going to finish my talk by showing you the two surveys that we created in Euro to Moon. There's one survey for propellant and one for regolith. We invite you to all be part of it, because all this data is what we need as an ISRU community, and of course, we're going to be sharing this data. And with this, I would like to finish, and I will be more than happy to take any questions later, because I think I ran out of time.
Thank you so much, Carlos, for sharing all these findings. Much, much, much indeed to share. And congrats already to you and your brand for M1, and looking forward indeed to share success on N2. Carlos, a quick one from my side. Knowing your background, and we are having a clear precision of what you want to be your achievements. And we are glad to see that you even have a commercial offering for us. And on that topic of that commercial offering, when we will start speaking pricing? Do you think that there will be a near to mid-future where we can speak as, I'm an industrial engineer, and I have a pleasure of sharing to a mining engineer, to have more people who want to get the offer? Do you think that we will need an idea of index or pricing? We are speaking to pile things around so that we can know who can get access to it. So at which given point do you think pricing or metrics will be key to have more currently demand takers, if we can bring it that way?
And you mean pricing for a resource?
Yes.
That's an excellent question. And for pricing, there's a really famous triangle of pricing, which is your cost, what the market is charging, and the benefit that you're adding if they were doing it on their own. So you need pretty much those three factors to then speak about pricing. In terms of market, as we saw, is just developing. So we need kind of to wait for that. So then we are becoming kind of that market standard. And the benefit we add, of course, is way more beneficial because we are going to be providing the service for you. But the question is, we are, of course, speaking about pricing, but in more and one-to-one B2B, because otherwise it's a bit, if you want, risky to put a price that everyone grabs as the market. But the most important part, of course, is the cost, the opportunity, the benefit you're adding, and whatever the market is going to be. But of course, we're discussing about it, we're working on it. Through this modeling, we estimated the cost, we estimated what the potential price is, which is very similar, to be honest, to what has been offered by ULA 5 years ago. And what they actually said is, this is an initial offering, you give us the price. But yeah, I think that's all I can share so far.
Great. Looking forward for some more confidential sharing. Carlos, thank you again for sharing with us, and looking forward to interact further with you. Thanks again. Big round of applause for Carlos. Thank you. And our last speaker of the day will represent Lunar Outpost Europe. Please, I welcome on stage Julian Cyrus. Julian, floor is yours.
All right. Good morning, everyone. My name is Julian Cyrus, and I'm the president of Lunar Outpost EU, right here in Luxembourg. Today, I'm going to be talking to you mainly about what we're doing here in Luxembourg, which is the Lux Thermal Energy technology. I'll give you a little bit of introduction about our company if you're not aware of it, talk to you about the need that there is for this technology, then talk about the technology itself as well as the development and some other applications, specifically terrestrial applications. So if you're not familiar with Lunar Outpost, we have 3 offices worldwide. As I mentioned, one is here in Luxembourg. The original office was founded in the US in 2017, and then we set up another office last year in Australia. We've, in the past, been primarily known for our lunar rovers and robotic missions. We have 3 fully ready missions to the moon. 2 of the rovers are built and tested and ready to go, just waiting on lander integration. The 4th mission, the Australian Space Agency mentioned yesterday, the Trailblazer program, we are currently competing on the ELO-2 team for that opportunity. You'll notice that in the mission 1, you see the LSA and ESA logos. That's actually because one of the technologies that we built here in Luxembourg is going to be flown on that. And that's a part of the Lux Impulse program, and it's been a really great opportunity for us to be a part of that. So the other offices that we have worldwide, as I mentioned, have a big presence in robotics and lunar mobility, in sensing as well. And here in Luxembourg, we focus mainly on thermal control and energy technologies. We were part of the startup support program with Esric, and as I mentioned, we're on the Lux Impulse program, which is funded by the Luxembourg Space Agency and in partnership with technical experts at ESA. So what we actually do here, these are the primary areas in which we work. The first, as I mentioned, is the Lux Impulse program, the Lux Thermal, the creation of that Lux Thermal system. Next is the creation of thermal components, such as our active thermal switch, as well as thermal capacitor that are used on for the satellites, landers, rovers. Basically, these components are used to enable these systems to survive in the harsh conditions of space. Here as a company, we also provide thermal engineering and testing services to kind of round this out and to provide the supplemental revenue to pursue some of these longer term missions and applications. So to get into Lux Thermal, which is really the heart of this conversation. The problem that we have, as everyone is well aware, is that long-term survival in space, specifically on the moon, is very difficult. And not only long-term survival, but enhanced operations also require extra energy. So we know that there's the problem. The actual scope and the impact of that is ever increasing. We know that there are many landers going to the moon, both commercial as well as from agencies. We've heard about the NASA Artemis missions, HLS, Lunar Terrain Vehicle, as well as Argonaut from ESA. And then on top of that, when you start to talk about ground operations, you've got your rovers, you got your ISRU facilities, and more scientific endeavors as well. And when you have especially advanced operations, like all the ISRU activities that we really want to do to enable sustainable presence, that of course is energy intensive. And if you're not taking all of your energy capabilities with you, then you need to have supplemental energy capabilities really enabled to let you accomplish all of those activities. So this is how we're doing it. Lux Thermal. This is something that we've been working on here in Luxembourg over the past 2 years in small pieces, and this is really the core of our long-term vision. What Lux Thermal actually is, it's an autonomous energy generation and providing system to provide thermal and electrical energy to customers on the moon. You see here that there is a client rover that is kind of come alongside this system, and it's being provided with electrical and thermal energy to enable it to have those enhanced operations as well as survive the lunar night. So no presentation is complete without a very general block diagram, so that's what this is. The Lux Thermal system is comprised of a couple key functionalities. The first, obviously, if you are going to be providing energy, you need to collect it. So that's what this is. On this system, you see a solar concentrator. We can also gain energy through other means if there's another opportunity to partner or to interact with another system. We can do that. However, in our first versions, the solar concentrator was the most effective way for us to create kind of a very well-rounded system to enable us to do everything from A to Z. So you start with the collection of the energy, and then you transfer it into a thermal energy storage system. This is a thermal reservoir that is really kind of at the heart of this Lux thermal system. From there, you have to be able to control your energy, which is where components like our thermal switch that we developed come into play. And then you shuttle it either to an energy conversion system, thermal to electrical conversion system, or you can provide it directly to the customer. So that customer has access to either electrical or thermal energy, depending on their specific needs. So this is kind of how we're getting there in the development of that Lux thermal system. So we started small. We started with our active thermal switch. As I mentioned, that is technology demonstration payload on board, actually our first 2 rovers that the US is sending up. That controls the flow of thermal energy from one point to another to allow systems to operate more effectively. The next step is the Lotus system, or the Lunar Outpost thermal energy storage system. This is basically a scaled down prototype of Lux Thermal. This is actually in testing right now. This is the CAD that you see is the testing setup that we will be completing in June. And the subsystems right now are in testing, and you'll see a picture of that here in a bit. Next step is LTEP, or the Lux Thermal Earth prototype. That system, it will reach PDR maturity by fall, and we are currently going through, we are relooking at the market analysis and customer needs in order to solidify the requirements and sizing for that system. So that's going to be, kicked off in a big way, really right now, and then it reaches PDR in the fall. And that is a 1-to-1 scale system that will be reach TRL5 and get us within striking distance of the ultimate Lux thermal system that we want to put on the moon. So Lotus, as I mentioned, it's currently in testing. We took it from design to analysis last year, and then are taking it from manufacturing into testing right now. That top CAD that you see is different than the one in the previous slide. This one was the one that was the original one for more space applications. So you see it's kind of wrapped in that MLI blanket. And then the analysis you see there is a thermal look at the system. Obviously, we've done vibration analysis and optics ray tracing as well, since you have the solar concentrator aspect. And on the bottom there, you have the reservoir, the tank that I mentioned is kind of the heart of the thermal energy storage system, and that is in this picture in our TVAC chamber at our office. So that's kind of the technology, the development path for it. And something else that is really important to keep in mind as we are building this out, these are parameters that you all are very aware of. In order to provide energy to a client rover like this, these are all things that are necessary in order to for this to be successful. Of course, operations, it's got to be working for long periods of time. It's going to have to do so autonomously, and it's going to have to do so in a low maintenance kind of way because we don't have access to it. We know that also the length or the longevity of this system will dictate how profitable it is, because there will be a sunk cost up front, and then the more that you can provide to clients, and we're planning on providing on via a watt-hour kind of subscription. So the more that you can do that over time, the more that you can recoup those costs and ultimately turn a profit on this. Availability, I mentioned the non-nuclear option. We wanted to focus on a non-nuclear option so that we could have less regulatory concerns and open it up for commercial customers as well. But as I also mentioned, there's different ways that you could essentially generate the energy and then store it in the system. So, if there is like a RHU, for example, or something like that, that can hook up to the system, then that's an alternative way to bring in more partnerships as well as to, enable this to be more successful. And then finally, extensibility. We don't want to just be, providing to rovers. We want to be providing to habitats, ISRU facilities, and stations of that nature as well. And then, so kind of bringing this back down, we know that we would like this kind of application in space. It's really enabling for all of the extensive operations that we want to do here on Earth. Now we're looking at the markets again, and where really this can, have an effect. As you can see here, based off of these numbers, the industry and transport and residential areas are really where energy consumption in the EU takes place. And if you think about, this system, what it can do, it is, taking in waste heat, if you will, and then reusing that, either converting it to electricity or, reusing that heat energy. And that is, energy valorization. And that concept is really, I think, core to how we develop space technologies, right? We have really a principle of limited resources in space, and so that's how we develop our systems. And it's a really good concept to implement back down here on Earth. So more specifically, areas of, we were thinking about, okay, where can this have a high impact? Also, where's there a lot of waste heat? And being in Luxembourg, this probably should have, come to mind sooner for us, but the steel industry is one that's huge. 10% of industry energy in the EU is actually put towards the metals and steel manufacturing. And you can see that there's a lot of potential gain to be made. We've estimated over $5 billion of energy is just purely wasted in this industry. Also mobility, with our robotic and rovers, in the US, this is a very natural place for us to provide value, in that, providing components like the switch on robotic applications also allows them to have enhanced survival capabilities and more energy efficient operations. So with that, thank you very much for listening. And again, thank you to Ezric, LSA, and ESA for the continued partnerships in this program.
Thank you so much. Thank you so much, Julian, for sharing with us how you're developing this capability from N1 vision to M4 right now, sharing about this public partnership to make this capability available. We understood the non-nuclear direction and also what you are seeing as players enabling this non-nuclear capabilities. My quick question will be, are you seeing that race to a given standard to be able to serve these customers already on the Lunar infrastructure, meaning that we have this race to be able to give one given model, one given standards? How could you have long-term survival with the solution you're providing?
Yeah, that's a good question. I think that there's definitely an impetus to reach that standard. I think, for us, the feasibility, showing feasibility of it, both for your company as well as the technology is the core thing. Once people see that this is a feasible technology and will benefit them, and it's reliable, because that's very important. If someone wants to plan out a lunar operation and they are promising their payload customers, they're promising, clients that, hey, we're going to survive for more than one day, then they're reliant on us as a provider. And so I think instilling them with confidence in our system and its capabilities is really the path to become that standard.
Thank you. I think we will continue interacting with Julian during the day. Thanks again, Julian, and we look forward to exchange with you during the day.
Thanks, Olivier.
Dear audience, I do believe that you had much takeaways that I had, and I'm looking forward to interact with the speakers of the day. And I thanks again OffWorld, RDSO, ispace, and Lunar Outpost. And we look forward of a great day sharing again and some takeaways of how to make lunar exploration and further commercial activity a reality. I leave now the floor to Lisa again. Thanks, Lisa.
Thank you.